For. Hi everybody, it's Keith. Welcome to Shop Talk. I'm with my best friend Bob.
Hey, and I'm with my best friend Keith.
And we're here to talk about everything that has to do with E3s and E4s and what's going on around here. We want to let everybody know that we are introducing a retrofit kit for our E3s and E4s. We've had a number of customers make requests. They want to be able to do spindle changes, go with maybe a little larger router or maybe a different type other than the DeWalt 660 that we use. And Bob, you want to tell us a little bit about what you did to get to what we have here?
Yeah, so like you said, we have lots of requests to say, hey, can I get something a little quieter? Can I get, hey, I have one of these in my shop, can I use this? Or we have some customers that have actually modified theirs and come up with their own mounts, with, you know, pretty clever out there. So, you know, since we've had a lot of customers asking, we thought, hey, you know, maybe we could make a kit so that if you did not want to design your own, you could just purchase one. So we came up with 3 of the most popular routers, combinations that we thought we had. First, we got the bigger DeWalt, then the Makita is a really good machine.
That's a 611, right?
Yeah, 611, okay. And the DeWalt, or I'm sorry, the Makita RT0701C.
Something like that. I looked it up.
And then we have the 52 millimeter spindle. They call it the quiet spindle. So these both have the variable speed. That one actually is a DC motor. I will say this, guys, that a long time ago when I tried one of these, I had some durability issues with the bearings, and I have heard that they have fixed that, but we have not tested any of these. They have not gone through our durability process, but they're within the weight range. The other thing that you're going to want to know if you decide to do this is because of the diameter. This one's 65 millimeters diameter at the router base, and this one's 60. That you're going to lose a little bit of your cutting area because it's going to hit the side, the X sides or the walls there. Right. So I think you're going to lose. It's under an inch, but you're going to lose a little bit. So we should have these out next week. The kit's going to come with the wood and the screws. You'll have to take your threaded rod and your nut and, you know, take that apart and put in your bearings and put it on this kit. So
and you're looking at 25 bucks?
Yeah, I think that's what we're going to do. I'm sure, you know, marketing will make it like $24.98 or something silly, but
it's 97 bucks.
97, sorry. 97. Now,
when you're looking on the screen, you're going to see pictures for the DeWalt and the Makita and the spindle. Just to make sure that we're clear, we want you to tell us which one you want, because you will only receive one kit per order, and that kit is going to have everything you need to create that Z spindle assembly. And since you've already put your kit together, all these things are going to make sense to you. You're going to have a complete instruction guide that's going to come, and of course great customer support from Bob CNC. So if you have any questions about these, you can get a hold of us at the help desk at bobcnc.com.
Right. And also if you're still wanting to make your own, we do sell the one that's the blank kit. I think it'll be a little less than this because we don't supply the design work or the screws with it, I don't think. But either way, but yeah, check us out. It should be out in a week or so by the time that you guys get this video up and going. And yeah, if you're interested in that, or if you've got some ideas for other changes that we can make, we're always listening. So thanks for your feedback. And again, there are several customers out there that have made their own. So if you're up to the challenge, go for it and send us those too, because we always love to see what people are doing.
Hey, we got a question from one of our customers, Tim. And he hit something that, well, I've had happen to me, and everybody's probably had in their shop. You're cutting out a project, and whether it's a great big long one that takes hours, or even one that maybe a couple hours and you're done, but somewhere through it a bit breaks, or I don't know,
UPS, freezes for some reason. Yeah.
Right. And so what do you do? I mean, do you have to start over and redo everything? Is there a way we can, start in the middle?
There must be a way to start in the middle.
Well, I don't know if there is or not, Bob. You could be teasing me here.
Yeah, actually there is, but it's not easy. But we thought that we could, well, actually, It is easy if you know how.
Oh,
right?
if you're Bob.
There's nothing. No, there's nothing hard about CNC work. It's just understanding what's going on.
Yeah, I know.
So what we're going to do is we're going to walk through and teach Keith how to do this.
Oh.
And if I can get Keith's light bulb to come on, I'm pretty sure I can get everybody else.
I just, you know, I've been debulbed.
Anyway, with that in mind, the first thing that we need to talk about, of course, is maybe some getting started. If you're going to run,
Kristen lost it.
Kristen, behave yourself. We're trying to do a professional video.
Okay,
here.
go ahead, Bob. I'm sorry. It's what happens when you lose your bulbs.
Okay, I'm going to continue on without him, and maybe he'll catch up here in a few minutes with no bulbs. So, first of all, if you're going to cut a 2 or 3 hour, 8 hour, or 10 hour carve, you're going to want to do something that, or get in the habit of doing something that I think that will help you out with this process here. So that would be is to make a point somewhere off your workpiece so that you can get back to it if something happens and you have to rehome your machine and everything to make sure you can do it. So here's what I would recommend. I would recommend that you go to your 0 point and get everything set up to where the 0 is, and then I would back up like 0.1 or 0.2 inches, 0.2 down, and then make a drill point with whatever bit that you're using, and then remember those dimensions, how far they are off the workpiece from the 0 point. So if I have it in the lower left hand corner, I would go, let's say, minus 0.2 inches in the X, minus 0.2 inches in the Y, and then I would turn my router on and then tell it to go down like, 0.05, 0.02. All I'm trying to do is get a nice bit-shaped cut in the piece of wood where I'm not planning on using it.
Right.
Now I can go back to 0 and start. Okay, so now I've run my program. It's a 7-hour program, and at 5 hours something happens, the electricity goes off, I break a bit, whatever.
Right.
I don't want to start all over. So how do I start somewhere where I left off? I wish I could say precisely, but this is going to take a little bit of judgment. But it sure would be better, instead of doing the whole 7, at least maybe doing 2.5 or 2 hours and 15 minutes of what you have left, right?
Shouldn't I? I mean, as the work is done, I'm seeing it process on the UGS screen.
Right.
But I can also take a look where my bit is and say, for example, I broke right there. So what can I do if that's my problem?
Okay, so what we're looking at on the screen is a program that you can go to. It's called NC Viewer.
Sorry, I did that to you.
Yeah. So of course it was. Anyway.
That's it. That's my
all right.
job.
So this is NC Viewer. There's another program called NC Corrector that you can download. It's really good for small files, but for 8-hour carves, it bogs down. This one's actually pretty good, and it's going to be a lot slower than we're doing today because this is a pretty simple file. But let's say that, like he said, that you got to your Y and something happened and then you wanted to start over.
Right.
So here is your G-code file over here. Here's the graphic screen. Now I'm going to take my mouse and we're going to just find that spot on the Y where we think that we stopped. And it's going to highlight the G-code over here, which is where it's cutting that toolpath. Now the thing that's important here is you got to stop, or you will want to stop, where the Z is coming out of the wood. So I'm going to look down through here until I find a G0 command, right? Because this means that the Z is going to move up. So I have a G0 Z.2. So I know that at that point my bit's going to come out of the wood because it's a Z. So what I'm going to do is I'm going to take everything above that and I'm going to just delete it, right? Not everything except for the header. So I want to keep the tool change maybe, which we really don't need, but the 17, the 20, the 90. As a matter of fact, I'll even keep my first Z command just to make sure. Now I'm going to go ahead and hit delete, and then I'm going to hit plot just to see what it looks like. And you can see that I'm really pretty good now. I'm starting at the UR. Now, you may notice that, hey, wait, where's the O? Well, in reality, the O was carved before the Y.
Right.
So it should have already be there on your piece of wood. So you could, now you're ready to go.
Okay.
So now you can just go ahead and save this file. If you're me, you would probably want to clean up this because you have 2 Z commands and you don't need them. You don't have to. So what's going to happen here is it's going to set it in inches, which is the G20. The G90 is absolute mode. And then it's going to say Z up a half an inch, 0.5. And then it's going to say, oh, no, I mean 0.2. So you don't need both of those. And then it's going to go to this spot right here where it starts. And actually, we could go ahead and just play it on the screen and see how this video turns out. But there it goes. It starts right where it needs to. So the idea would be is you would be able to save this file, rehome,
Right.
go find your point that was at minus 0.2, right? Make sure that that's what the coordinate systems are. Go back to 0, load this file, and then you would be able to finish where you started.
Now, as a kind of a lesson, a skill development thing, you could actually create a little file of your own and try this and shut your machine off and set up your own failure and then go back and practice this a few times.
Absolutely.
Until you get the logic of it.
Yeah, not on an 8-hour file though. That would take a lot of time.
No,
you'd want to do that. So yeah, so that's really there is no easy way to do it right now. I mean, one thing I think would be really cool is if in UGS it would kind of count, hey, I've done this one, I've done this one, I've done this one, and if something bad happens where it locks up, right, it just says, write something to a file and says, I was on line 768.
Right.
I mean, that would be kind of cool.
Why don't you do that, Bob?
I'm not a very good programmer, but maybe I could ask Will to do that.
Okay.
From the guy from UGS that maintains this software, is the lead developer, I guess I should say. But if we could have something like that, that would be cool. But I'm not sure that would work, because sometimes gerbil keeps going and it doesn't know that it's crashed. It doesn't know that the bit's broken. So you come back and you may miss 5 minutes of it.
Right.
So it really is probably a better idea to actually learn how to look at a G-code file and figure out where you're at, and also make a backup copy, because if you're wrong, you'll want to, I cut out too much, and now I don't get the Y. Right. So you can go back and do it again. So I hope that helps everybody. If not, please send your questions to our help desk at bobcnc.com. Do we have anything else today, Keith?
I think that's it, Robert.
All right. Robert.
You like that?
I'm official.
I'm trying to get a raise.
Thanks.
Hey, guys, you have a great day.
All right, see ya.